Hi everyone, today we're going to be doing a nice little geometry problem. So we've got a right triangle whose circumference, namely a plus b plus c, is equal to 24 centimeters, and whose radius of the inscribed circle is 2 centimeters. Given this, we're supposed to find the area. First, let's find the lengths of the sides of this right triangle, and we're supposed to find its area last. So all of this is unknown. So I've made a sketch right here, and I want us to notice a couple of rules. So it says that a plus b plus c is equal to 24 centimeters. I'm not going to write down units. For now, I'll just write them at the final result, with the final result. And what I also want us to notice is that this is a right triangle. So since this is a right triangle, we can use the Pythagorean theorem. So a squared plus b squared plus is equal to c squared. And once we take out the square root of both sides, we'll get that c is equal to a squared and to the square root of a squared plus b squared. Let's just go ahead and plug that right here. So then we'll get that a plus b plus the square root of a squared plus b squared is equal to 24. I'm going to isolate the square root on the left hand side, and that will give me that a squared plus b squared is equal to 24 minus a and minus b. Now I'm simply going to square both sides, and that will give me that a squared plus b squared is equal to, once we expand all of this out, that's going to be a squared plus 2ab minus 48a plus b squared minus 48b and plus 576. Of course, we can just go ahead and cancel out a squares and b squared. And going from here, we'll get that 48a plus 48b minus 2ab is equal to 576. I'm going to divide both sides by 2 just to make it a little bit simpler. And no, we don't have a square here. So 48a plus 48b minus 2ab is equal to 576. Once we divide everything by 2, we'll get that 24a plus 24b minus a times b is equal to 288. Of course, we can factor out either one of these. I'm going to factor out a, and that will give me that a times 24 minus b is equal to 288 minus 24b. And from here, it follows that a is equal to 288 minus 24b over 24 minus b. And of course, I'm just going to rewrite that as 24b minus 288 over b minus 24. So that's the first part that's going to help us out a little bit with solving this. And the other part that I want you to notice is, I'm just going to erase this part right here. Whoops. The other part that I want you to notice is that we can draw several more triangles within this triangle, like so. These are all right angles. These are all right angles. Okay, so this is a right angle, this is a right angle, and let's just go ahead and draw this one as well. And this of course is also a right angle, and this of course is also a right angle. Now, since we know that the center of the inscribed circle lies lies at the point where the symmetrals of the triangle's angles intersect with one another, that means that this angle is equal to this angle, and that this angle must be also equal to this angle. And since we know all of these are r's, okay, that means that by using the side-side angle theorem, we can conclude that this triangle is exactly the same as this triangle, and that this triangle is exactly the same as this triangle. Okay, so what does that tell us? I want you to notice that this part right here is r, this part right here is b minus r, and this and all of this must be equal to b. And I also want you to notice that this part here is also going to be r. So this is r, and this here is a minus r, and all of this is a. And since we've already concluded that all of these triangles, that these blue triangles are identical, and that these green triangles are also identical, that means that this part right here must also be equal to b minus r, and this part right here must also be equal to a minus r. That means that a minus r plus b minus r must be equal to c, and we know that c is equal to the square root of a squared plus b squared. So we can simply rewrite this as a minus r plus b minus r is equal to the square root of a squared plus b squared. I'm going to go ahead and plug in these numbers. Instead of r, I'm going to plug in 2, and that will give me that a plus b minus 4 is equal to a squared plus b squared, and of course I'm going to square both sides. So once I go ahead and do that, on the left hand side I'm going to get that a squared plus 2ab minus 8a plus b squared minus 8b plus 16 is equal to a squared plus b squared. Cancel out all of the square terms, and we're left with that 2ab minus 8a minus 8b plus 16 is equal to 0. I'm going to divide everything by 2, so then we'll get that ab minus 4a minus 4b plus 8 is equal to 0. And I'm going to factor out the a again, so that will give me that a times b minus 4 minus 4b plus 8 is equal to 0. Or, in other words, from here it follows that a is equal to 4b minus 8 over b minus 4. And this is going to be the other part of our auxiliary step. So from here we get, so from the first equation we have a as one function of b, and from the second equation we have a as another function of b. So we're going to make them equal, or in other words we can write that 4b minus 8 over b minus 4 is equal to 24b minus 288 over b minus 24, and I'm going to go ahead and divide everything by 4 to make it a little bit simpler. So we get that b minus 2 over b minus 4 is equal to 6b minus 72 over b minus 24. Now we can just go ahead and cross multiply everything. So b minus 2 times b minus 24, that will give me b squared minus 26b plus 48 is equal to b minus 4 times 6b minus 72, which is simply equal to 6b squared minus 96b plus 288. And once we put everything on the same side, we'll get that 5b squared minus 70b plus 240 is equal to 0. We can divide everything by 5, and that will give us that b squared minus 14b plus 48 is equal to 0. Now by using the quadratic formula, we'll get that b1 slash 2 is equal to 14 plus or minus 14 squared, which is 196 minus 4 times 48, which is equal to 192, and everything over 2. And this is essentially the same as 14 plus or minus the square root of 4, which is just 2 over 2. So b1 is equal to 6, and b2 is equal to 8. Once we plug in these values to either equation 1 or equation 2, we'll get that a1 is equal to 8, or that a2 is equal to, and that a2 is equal to 6. c1 is the square root of a1 squared plus b1 squared, which is the square root of 64 plus 36, which is the same as the square root of 100, which is simply 10, and the same is true for the other one. So we've found the sides of our right triangle. Great. And finally, we just have to find the area, and that's going to be very simple. The area is simply, for a right triangle, a times b over 2, and you can plug in either a1 b1 or a2 b2, it doesn't really matter because their product is the same. So that's going to be, let's say, 6 times 8 over 2, and 6 times 8 is 48 over 2, which is equal to 24. So A area is equal to 24 units, and these are our sides. All of this together constitutes our final answer to this problem. I hope you enjoyed the video. If so, leave a thumbs up and subscribe. I'll see you in the next one.